Section 4.7, Exponential and Logarithmic Models. In this section, we'll model exponential growth and decay, and we'll choose an appropriate model for data. So this is the exponential growth and decay model, which we've seen before. So y is going to represent the final amount present. A sub 0 represents your starting or initial amount. K is your growth or decay factor. And T is your time. So we've seen this model before, and in this section we're just going to use it to model some situations. All right, so let's take a look at modeling exponential growth. In the year 2000, the population of California was about 34 million. By 2010, the population had grown to 37.3 million and had been growing exponentially. Find a function that models this exponential growth. What was the growth rate of the state during this time? So since we're told that the growth is exponential, we're going to use our formula y is equal to a sub 0 e to the kt. And in this problem, we're given some data, but we don't know what k is. And so we're going to need to plug in values for t, for a sub 0, and for y that will allow us to solve for k. All right, so in this problem, time is going to start in the year 2000, and then it's going to go to 2010. So our time is going to be 10 years. This is our starting amount. So a sub 0 is going to be 34 million. And this is our ending amount. So this is going to be what we replace for y. So let's go ahead and do that. So 37.3 is equal to 34 e to the t is 10 and k is what we're trying to solve, 10k. And so this is simply an exponential equation. So remember, to solve an exponential equation, we're going to get the base by itself. So we'll start by dividing both sides by 34. So we have 37.3 divided by 34 is equal to e to the 10k. And remember, the way we solve an exponential equation is by taking a log of each side. And I'm going to take the natural log of each side because when I use the power rule to bring down the power, we'll have the natural log of 37.3 divided by 34 is equal to 10k times the natural log of e. Now remember, we've talked about this. This is the nice thing about using natural logs. The natural log of e we know is equal to 1. So we multiplying by 1 doesn't change the value any, so we can just ignore it. And then to solve for k, we would simply take this expression and divide by 10. And so in our calculator, we're going to put natural log of 37.3 divided by 34. We'll take that answer and divide it by 10, and that will give us our k. All right, so let me go ahead and do that on my calculator. So natural log of 37.3 divided by 34. I'm going to take that value and divide it by 10, and I get that k is equal to 0.0093. All right, so what does that mean? That means that we can model the growth in California's population by y is equal to, our initial value is 34, e to the k we found out is 0.0093 t. So in terms of percentage, what that means is that the population was growing at a rate of, and if we change this into a percentage, about 0.93% per year. All right. Use the function to predict the population of California in the year 2020. Now remember, this model is based on starting in the year 2000. So to answer question B, the year 2020 would be a t value of 20 years later. So we would simply take our calculator and go y is equal to 34 e to the 0.0093 times 20. So let's go ahead and do that. So we'll have e to the 0.0093 times 20, and we'll be multiplying that by 34. And so that would tell us the prediction was 40.95 million people. When does the function predict the population will reach 60 million? So now this would be our final amount, and we need to solve for t. So we're going to go back to this growth model that we developed. We want our final amount to be 60 million. And what we need to solve for is t. So again, we have a variable in the exponent. So to solve for t, we'll begin by dividing both sides by 34. That tells us that 60 over 34 is equal to e to the 0.0093t. And again, the way we are able to access the variable in the exponent is by taking a log of each side, because by the power rule, we can now bring down that power from the exponent. So we have natural log of 60 over 34 is equal to 0.0093t times the natural log of e. Now we know with the natural log of e, that's equal to 1. And so to solve for t, we'll simply take this equation and divide by 0.0093, divide by 0.0093. So let's enter this into your calculator. We're going to take the natural log of 60 divided by 34. And we're going to take that result and divide it by 0.0093. And we get a t equal to 61. So to answer the question, remember that it's asking when. So t equals 61 doesn't really answer that question. It helps us answer the question. But if time started in the year 2000, that means this will happen in the year 2061. All right.